Good morning, grade 7 class. My name is Miss Monacheng and welcome to your term 3 class on numeric patterns. So before we get into the lesson, guys, I just want to tell you guys about the lesson goals and the lesson objectives that we need to get through this lesson. Firstly, we're going to look at what is a numeric pattern. Secondly, we're going to look at different numeric patterns that either have a constant ratio or a difference ratio. Like we know, grade 7s, we do not treat each other like blank slates. We all have some pre-existing knowledge about what a numeric pattern is. Just from listening to the word numeric patterns. Numeric is very closely linked to the word numbers. So we now are able to insinuate or rather understand that numeric patterns deals with what? Numbers, right? It's a list, a series, a continuation of numbers in a chronological order or using a chronological rule. So here the definition says it is a sequence of numbers, hence it is a numeric pattern and it follows a specific rule. This is very, very important because you won't find that to get from term 1 to term 2 you added maybe 7, then in the middle of the pattern later on you need to add 7,000. No, the pattern is consistent, right? Then it says it can either have a constant or different ratio. We're going to break this down in our lesson today. Number 4, I want us to quickly look at these examples that we've seen, right? From grade 4 right up to today, grade 7. 2, 4, 6, right? To put on your numeric pattern cap on, guys, firstly, you need to look at the first term. The first term is a big indicator of what is going to follow, all right? And it is very, very essential. When we look here, the first term is 2. The corresponding, or rather, the term that follows is what? 4. Now you put your thinking cap on. You're like, so for us to move from 2 to 4, what happened? Did the pattern become bigger? Did the numbers go up? Correct, they did. From 2 to 4, it went up. So now you need to look at your orders of operations. We've got addition, subtraction, multiplication, and division. And we know that with multiplication and addition, we're making numbers bigger. So now we need to look, okay, we know that we're going to be working with either one of these two, or even both of them. So to move from 2 to 4, we can gladly say that we've added the number 2. Or we can also say that we've multiplied the number 2. Third point of everything, right? I told you guys we're going to be looking at patterns with a constant difference or a constant ratio. Correct. So let's just focus on the constant difference for now. So what this entails, guys, this is a fixed number you can either add or subtract to get from one term to the next term. So this is pertaining the rule of the numeric pattern. When we look at this, for example, this example here, 50, 45, 40, what is happening to the numbers? They are decreasing. Then we look at the two orders of operations that help us decrease numbers. We're looking at what? Division and subtraction. But since we're concentrating on constant difference, it means we're only going to look at what? Subtraction. To move from 50 to 45, what did you do? Subtracted 5. 45 to 40, subtracted 5. So this is the constant difference of this numeric pattern, and it is the rule for the pattern. So for the following terms, we will continue subtracting 5. 40 subtract 5 is 35. Next term, subtract 5 is 30. You get your mark. We're going to do the same this side. Look at that example. 3, 7, 11. Now we're seeing that the numbers are getting bigger. We know with constant difference, when it gets bigger, it means we need to add. So how do we get from 3 to 7? What you can do, subtract the second term and the first term to get your constant difference or the rule of your pattern. So 7 subtract 3, what is that? It's 4, meaning we are increasing by 4. So 11 plus 4, what is that going to be? 11, 12, 13, 14, 15. Plus 4 again, 19. So that is the rule of our pattern. That's the constant ratio. When you guys look at the constant ratio, I expect you guys to be thinking about multiplication and division. Let's read the explanation. This is a fixed number you can either multiply or divide by to get from one term to the next. Let's look at the example that it gives us. 3, 6, 9. Right. So as you can see, the pattern is what? Increasing. So if it increases, you know that the order of operation that you need to look at is multiplication. So from 3 to 6, what did we do? We multiplied, correct? Now, by how much did we multiply? This is where your multiplication skills need to kick in now. So we know that for us to move from 3 to 6, we need to multiply by 3. Another way to get to the rule or the constant ratio is you need to use inverse operation. What is the inverse operation of multiplication? The opposite of multiplication is division. So you can divide the two terms. 6 divided by 3, you get 3. Then you know that the rule is multiplied by 3, multiplied by 3. So to move from 3 to 6, multiply by 3, multiply by 3, 8 times, 9 times 3, 27, and so on and so forth. So remember, grade 7s, the whole purpose of this lesson, guys, is on numeric patterns. So we need to address certain instructions that come with numeric patterns. So let us investigate, rather, right? We're going to investigate, is it a numeric pattern? Does it have a constant ratio or a constant difference? Let us identify the rule for the pattern, and let us extend, meaning that let us add to the terms that are already there using the rule that we have. So we're going to look at this. First one, 725, second term, 750, third term, 775. First question, is this a numeric pattern? Yes or no? The correct answer is that it is a numeric pattern. How do you know this? Because it is made from numbers and it is continuing, right? It is a sequence or list of numbers with a fixed or general term. So we're going to write yes, you get a tick there. Next two terms, correct? What would the next two terms of this pattern be? We're looking there. 725, 750, 775. Are we going to multiply? No. Are we going to subtract? No, because it's getting bigger. Are we going to divide? No, because it's getting bigger. We're only left with one order of operation, addition. So for us to move from term 1 to term 2, what did we do? We added plus 25. Does this plus 25 also apply for us to get from 750 to 775? Correct, it does. Plus 25. So now we know that we need to look for our next term. 775 plus 25 is going to be 800, right? 800 plus 25, 825, and you get a mark just like that. Then it's asking us, what is the rule? Is there a rule? Correct, there is a rule, and our rule is plus 25. Always do not forget the order of operation. Then here, do we have a constant ratio or a constant difference? We used which order of operation? Addition, meaning it is a constant difference. You get a mark there. Let's look at question 2. 3, 12, 48. How do we get from one term to the next? Is it a numeric pattern? It is a numeric pattern, correct. Why? Because it is a series or a sequence or a list of numbers that follow a fixed rule. From 3 to 12, what did we do? Sorry, let me just write the answer here. What did we do? Is the number getting bigger? Yes. From 3 to 12, 12 to 48. What a big jump that is, right? So did we multiply? We did multiply because we didn't add. There's nothing that we can add that can help us have a general or a fixed rule for this term. Did we divide? No, it keeps getting bigger. Did we subtract? No, because it keeps getting bigger. So from 3 to 12, what is the rule? How did we get there? Remember when I told you that you can use what? The inverse operation to get to the next terms. The inverse of multiplication would be division. And 12 divided by 3 is 4. So meaning the rule is multiplied by 4. So now we need to find the next term, the next two terms of this pattern, right? So we need to continuously multiply by 4 because 12 multiplied by 4 is 48. 48 multiplied by 4 is going to be what? So you need to have 4 48 basically if you want to use that method. But our general answer is going to be 192. 192 multiplied by 4 is going to be 768. and you get your marks like that. Then it says the rule. Do we have a rule here? We do, and it is a fixed rule. Multiplied by 4. Is it a constant ratio or a constant difference? Remember, with difference, we look at the orders of operation, addition and subtraction. With ratio, we look at division and multiplication. So indeed, it is a constant ratio. Quickly recap on what a numeric pattern is. Remember, a numeric pattern consists a sequence, right, of numbers, correct, that follow a specific rule that can either be a constant ratio or a constant difference